Earth, our fragile home, a small blue sphere drifting through a vast cosmic sea. Every person who has ever lived, every tale ever told, every memory and hope we hold, all exist on this single, pale globe. But to understand how truly immense the universe is, we must pull back. Past our air and clouds, beyond the moon's familiar presence and the warm glow of our star, we begin a journey outward, a voyage to measure scale itself. The first stop is the moon, roughly 384,000 kilometers away. That's a span so large that driving non-stop at 100 kilometers per hour would take well over 160 days to arrive. From there, Earth shrinks to a delicate ball of blues and greens set against the black of space, a sight that humbles us and sharpens our sense of how small our problems can be. Continuing outward, we come to the Sun, 1 astronomical unit from Earth, about 150 million kilometers. Light from that furnace races at roughly 300,000 kilometers per second and needs about 8 minutes and 20 seconds to cross that gulf. If you attempted the same trip in a commercial airliner cruising near 900 kilometers per hour, it would take around 19 years. Even inside our own neighborhood of planets, distances are vast beyond everyday comprehension. The Sun, a blazing source of energy, powers the delicate conditions that make life here possible. Beyond the Sun lies Mars, our red and mysterious neighbor. When the planets align most favorably, Mars can be as near as about 54.6 million kilometers. At other times, when the two worlds are on opposite sides of the Sun, that separation can swell to roughly 401 million kilometers. Flying there at jet speeds would require decades. It's precisely this scale, coupled with shifting orbits, that makes missions to Mars technically challenging. The robotic explorers we've sent must navigate changing distances, radiation, and complex entry and landing dynamics to reach that distant, dusty world.
Farther still sits Neptune, the distant ice giant, some 4.5 billion kilometers from Earth, a boundary of the familiar solar neighborhood. Sunlight takes a little more than 4 hours to travel from the Sun to Neptune, a testimony to how expansive our system becomes when measured in planetary terms. Launched in 1977, the Voyager 1 probe embodies humanity's drive to push outward. Over more than 4 decades, it has become the most distant human-made object, traversing tens of billions of kilometers and slipping beyond the region where the Sun's influence dominates. When Voyager 1 turned its gaze back toward home in 1990, it captured an image in which our planet was no more than a faint, almost invisible speck. A reminder that from far away, what seems enormous to us is minuscule in the cosmic scale. That image invited a quiet reflection about our responsibility to this fragile world. At the very limits of the Sun's reach, theorists place the Oort Cloud, a vast spherical shell of icy bodies that may extend to roughly 100,000 astronomical units, edging toward interstellar space. That expanse is measured in such enormous units that it borders on 1 or 2 light-years, distances where the Sun's wind thins and the interstellar medium begins to dominate. The heliopause, the frontier where solar wind meets interstellar matter, marks the end of the Sun's domain and the beginning of the true interstellar ocean. Beyond our star system, the nearest stellar neighbor is the Alpha Centauri system, at a distance measured in light-years rather than kilometers, about 4.4 light-years away. When distances reach this magnitude, astronomers prefer the light-year because astronomical units become impractically small. To put it in human terms, with current spacecraft speeds, a probe would require tens of thousands of years to reach such a star, an almost unfathomable time span that underlines the challenge of traveling between the stars. Stepping back further, we find our galaxy, the Milky Way, a flattened spiral disk roughly 100,000 light-years across, containing hundreds of billions of stars. Nestled within this mass of light, is a tiny sphere of human influence, the bubble of radio and television signals we have sent into space, extending only about 100 light-years. Outside that bubble, the galaxy is silent with respect to our presence. Most civilizations, if they exist elsewhere, would be unaware of us because our broadcasts have not reached them. Our recorded history is but a whisper against the Milky Way's vastness. Crossing the boundary of our galaxy, we enter intergalactic space, an almost empty ocean dotted with islands of galaxies. Our Milky Way belongs to the local group, a collection of more than 50 galaxies spanning roughly 10 million light-years. The stretches between galaxies here are so enormous that light can take millions of years to travel from one edge to another, a scale that dwarfs anything inside a single galaxy. Beyond the local group lies even grander structure. We are part of the Virgo supercluster, a massive assembly of galaxy groups and clusters extending across on the order of 100 million light-years. And beyond that lies Laniakea, our supercluster on the largest known scales, a titanic web of galaxies spread over hundreds of millions of light-years. At its core are regions like the so-called Great Attractor, areas where gravity gathers galaxies together, subtly steering their motion across the cosmos. Within such structures, our galaxy is an infinitesimal part of a vast gravitational dance. Finally, at the limits of what we can observe, lies the observable universe, a sphere roughly 93 billion light-years across. That number sparks a question. If the universe is around 13.8 billion years old, how can the observable cosmos be so much larger? The explanation is cosmic expansion. Space itself has been stretching since the Big Bang, carrying galaxies away from one another and extending distances faster than light can cross them. Some regions recede so rapidly that their light will never reach us. They lie forever beyond our view. What exists beyond the observable universe is unknown, and perhaps unknowable. The universe might be far bigger than what we can see, or possibly infinite. As we pull back to the largest scales, the sense of perspective is overwhelming. Our planet, our species, even our galaxy, all are tiny elements of a fabric of staggering size and complexity. And yet, inside that tiny speck, consciousness arose, beings who can look outward, count the distances, and marvel at the enormity that surrounds them. That capacity to observe, to measure, to wonder is the human story writ across the cosmos. What we see is enormous. What we imagine may be even greater.